Right, what up everybody? This is Mr. Stan coming at you with another video. This time we're talking about constructive and destructive interference, right? So on the screen now you see the two wave patterns, right? So this represents two waves that are at the same place at the same time. And so in real life you wouldn't see two different waves, you would just see one wave that's made up of both of these waves of energy, right? And so the question is, what is that going to look like um, if those two waves are at the same place in the same time? And to understand that, we have to understand what is constructive interference and destructive interference, right? So constructive interference is when the two waves add together in order to build it up, to make it a higher amplitude. Whereas destructive interference is when adding the waves together results in a smaller amplitude, right? So this example we see is constructive interference. You see the red wave and the blue wave at any point on that graph. Um, if the red wave is on the top half, the blue wave is on the top half. If the red wave is on the bottom half, the blue wave is on the bottom half. And so those would add together and they would build each other up. So you, at any point, you could take how high the blue wave is plus how high the red wave is, and you would get this purple wave down here. So this purple wave is what you would actually see, right, if those two waves of energy were together at the same place. Right, destructive interference is when some of that energy kind of cancels each other out. The energy is there, but it's going to make the amplitudes not as high, right? Because some of that energy is working to bring the medium down, some of it's working to bring it up. So look at this example. You see the blue wave and the red wave are always on opposite sides. So when the blue wave is on the top half, the red wave is on the bottom half. So what that means is the energy from that blue wave is kind of trying to force the medium to go up, and the energy from the red wave is trying to force it go down, right? And so when that happens, you get that right there. You get a wave that is not as high in amplitude as before, right? Now, in your homework, if you're doing the packet, you have examples that are more like a real world example where you have waves that don't necessarily look like each other. Some are longer and shorter, and so there's going to be parts of this pattern where the interference is constructive, and there's going to be parts of the pattern where the interference is destructive, right? So let's see how you would figure that out. The question you have to ask yourself is, are the two waves on the same side of that horizontal line? The horizontal line represents where that medium would be if there was no energy, no wave going through it, right? So if all this energy passed, then whatever medium, whether it be like a string, the ground, water, whatever, it would all reach that kind of level surface that you see in the middle. So if the red and blue wave are both on top, it's going to be constructive. If the red and blue wave are both on bottom, it's going to be constructive. But if one of them is on top and one of them is on the bottom, then it becomes destructive. So here you can see some examples, right? At point A, the red and the blue wave are both above the horizontal line, right? So they're both on top. That means their energies are going to add together to make a bigger amplitude. So that's constructive. Same thing with C. If you notice at point C, both the red wave and blue wave are below that horizontal line. So they're still working together. That's considered constructive interference. So you would see a kind of a lower trough once these waves add together. But at point B, in the middle there, you see the blue wave is on top, the red wave is on the bottom. That's destructive interference. As a result, you're going to get a smaller amplitude part of that wave. Right? At point D, the red wave is on top and the blue wave is on bottom. So that's going to be destructive interference. And then when you get back to point E, both the blue and red wave are on top, so that's constructive interference. If you add these two waves together, what you would actually see is something like this, like you see on the bottom here, right? So notice that where there's constructive interference like A and E, you get a bigger peak, a bigger crest, as the official name is, crest. Right, but at points B and D, you'll notice that it's closer to the horizontal line because you have destructive interference. All right, I'll see you all later in another video. Have a good day and happy studies.